Hello there, we're dorakemon. We have created a secure lab access system app and are demonstrating how it works. Using this app, our lab members can open our lab door lock without revealing their identities. Let us demonstrate how to use this app, showcasing scenarios involving both a malicious user and a valid user. For clarity in this demonstration, we have set the door lock's QR code inside the room. However, in a real-world scenario, the QR code should be placed outside the room. In our verifiable credential ecosystem, we have introduced an additional role to the standard triad of issuer, holder, and verifier, the opener. In our system, when holders want to access the room, they present their verifiable credentials to the verifier. By utilizing BBS plus signature scheme and zero-knowledge proof along with the opener's public key, their identity information is selectively concealed. This allows them to prove they are valid lab members without revealing their personal identities. However, the role of the opener is a pivotal aspect of our system. The opener using their private key is the only entity capable of revoking this anonymity and identifying the individuals. First, we are demonstrating as a malicious user. The user selects attributes to present to the verifier. In this case, to prove that we are a valid lab member, we need to present the lab name, but other information is not necessary. So he only chooses the lab name. Verifier will notice his lab name is malicious lab, indicating he's not a valid lab member. He scans the QR code to present his verifiable presentation and clicks present to the DID. Send. However, as you can see, even though there is a message new VP is received, there is also a message laboratory not matched. The system denies his VP due to his invalid VP. Next, we are demonstrating as a valid user. To begin, he checks the door is truly locked. Then, he selects his student card as his verifiable credential and picks the lab name and the university name to prove his belongings to this lab at our university. He scans the QR code and clicks the button, present to the DID. Clearly, this time the door unlocks, confirming his status as a valid lab member. He can open the door. Yay! Sometimes, even though only authenticated members can access the lab door anonymously, they might leave the room messy or dirty. The challenge here arises from anonymous access. It's unclear who's responsible for the mess. This is where the opener role in our system becomes crucial. Let's look at the opener app interface. The process begins with the opener retrieving the previous day's entry log to the room and integrating the disclosed VC information. A critical step involves the opener's private key. There is a designated field in the app for its input. This key is essential for revoking the anonymity associated with the VC. Upon entering the private key, the opener clicks the Revoke Anonymity button. Immediately below this button, two important sections are displayed: UID data and Open VC. In a typical VC ecosystem, the opener would need to contact the issuer to identify the individual associated with the UID. However, for the sake of simplifying our demonstration, the opener bypasses this step. The opener can directly identify which lab member accessed the room the previous day. Thank you for watching this demonstration video.